Hello, welcome to Copernicus Virtual Classroom. My name is Pat and I'll be your educator today. This lesson is going to be about rockets. How to make rockets. You're going to make one out of paper and then you'll have some activities to perform with your rocket. But first, let's talk about real rockets. If you've ever seen a rocket launch, you know it takes a lot of energy, a lot of force to get that rocket off the launch pad. The amount of thrust determines how far and how fast a rocket can go. That would be with Newton's first law that says that every object stays at rest or travels in a straight uniform line of motion unless it is compelled to change by force. So what that means is before firing a rocket, the rocket stays at rest and the airspeed is at 0. When the engine is fired, the thrust increases from 0 and the weight decreases slightly. So as the thrust increases, the weight decreases. When the thrust is greater than the weight, then the force goes upward and the rocket speeds forward in a straight line. I have a short video to show you of the launch of NASA's Space Shuttle Discovery in April 2011. Notice the enormous amount of thrust needed to get the rocket to launch way up into the atmosphere.
Seconds from the launch of Space Shuttle Discovery. T-minus 60 seconds and counting. We're transferring to orbiter internal power at this time. Discovery is now running off its 3 onboard fuel cells. Coming up on a go for auto sequence start. And we have a go for auto sequence start. Discovery's onboard computers have primary control of all the vehicle's critical functions. T-minus 17 seconds and counting. 15, 12, 11, 10, 9, 8, 7, 6. Start. 2, 1. Boost ignition and liftoff of the Space Shuttle Discovery, returning to the space station, taking the way to missions beyond.
converging. Discovery's onboard computers commanding the main engine nozzles to swivel, aiming the shuttle for its precise target in space for main engine cutoff.
Shoot everything forward like now and then. Sound good. Discovery Houston, negative return. Copy, negative return.
Okay, so now it's time for us to build our own rockets. To build your own rocket, you're going to need these materials. You have a printout of the template that we need to build our rocket, the parts that we need. You should have a pencil and a drinking straw, a pair of scissors, and some tape. Those are all you need to make your straw rocket. Now the thrust that we're going to use to make our rocket go will be our mouths, will be air. It's an air rocket. And
Okay.
I gotta put this thing down.
Okay.
The
The thrust. You can do the thrust thing.
The thrust for our rocket will be air, and so when we have our rocket built, we will blow through the straw, and that will be the thrust to push our rocket out. Now, what you're going to need to do, first of all, is to cut the pieces out, and we have these parts. When you get them cut out, you'll have these parts here. Now, the parts on a rocket are the fuselage, which is the long piece here, the body of the rocket, the nose cone, the pointed part up at the top, and then the fins down at the bottom. The fins will help steer your rocket. So, our rockets will look like this. We will have the fuselage, which will be this long piece of paper here, and then our fins will be these pieces here, and then we will be wrapping the fuselage around the pencil. And then when we're done, when we take the pencil out, we'll put the straw in, and that's how we'll blow the straw through the straw to make the rocket go. So, what you need to do right now is to start out by cutting your pieces out, and you may pause the tape right now so that you can get your pieces cut out. Okay, now that you have your pieces cut out, what we're going to do is start by taking our fuselage piece, and with the Copernic emblem on the outside, we're going to roll that piece of paper around the pencil, holding it very tightly around the pencil. And it's probably easier if you do it down on the table and roll it tightly around. And then take a piece of tape and put the piece of tape right there in the middle to tape it together. Okay, so now you'll notice though, we have to tape that whole seam. See the piece of tape right here in the picture? It covers the entire seam all the way down because we don't want any air to escape out. So now we'll just take some more tape and tape up the whole way down, the long way, all the way down. Okay, so you have that taped up all the way down. Now don't tape it to the pencil. We don't want it to stick. We want the pencil to be able to come out later on. But there should be no holes along that whole way. All right, so next we're going to take our flaps and we're going to just tape those onto the pencil. So we just take a piece of tape and we'll tape the flaps on around like this and then down around here like this. Again, don't tape it shut. You want the pencil to be able to come out later. Then we take the other flaps, and on the other side, we want to take a piece of tape, and up here, put a piece of tape there, attach those flaps, and another piece down here, attach those flaps, and then you can bend your flaps like this and like this, so then you have your flaps all around your rocket. Okay, so now we can take the pencil out and we want to make the nose cone up at the top. The easiest way to make your nose cone is to just kind of flatten it and scrunch it together into a point. Maybe twist it a little bit. Doesn't have to be perfect. But you're going to have to tape it shut because you don't want any air to escape out of your nose cone. So make sure that you put the tape all around the top so no air escapes out of the nose cone. Because if any air escapes, your rocket won't go very far. And the way that you can test that is to blow in from the bottom. And if you feel any air coming out, then you know that you have to make sure that all of that is taped up. Okay, so there's our rocket. We're going to try some different tests with our rocket. But first of all, you're going to need a target. When we watched that NASA launch, they said that the shuttle was on target for its orbit. So what you can do is stop the video and make a target that you'd like to aim your rocket at. You could download a picture of your favorite planet or the moon, or you could make a target like a bullseye target. You could draw a picture of your favorite planet or the moon. You could make a game out of it. I've made a picture of, anybody know what planet that is? That's Jupiter. Well, that's my drawing of Jupiter. You can tell by the big red storm there on Jupiter. I made another target that maybe I want to play a game with one of my family members, and I can shoot it towards, get different points on my target. So use your imaginations, and you can stop the video now and make a target. Okay, well, welcome back. I hope you have your rocket and your targets ready, and we'll get started using our rockets. I'm going to tape my target right here, and I have my straw. So I'm going to put my straw inside my rocket, and now I'm going to just blow through there and see where my rocket goes. Now, the thrust, if I blow very softly, my rocket will go, you're right, a short distance. If I blow hard, you're right, it'll go a long distance. So let me try hitting my target of Jupiter. Oh, close, close. Let me try again. Oh, so you can see you have to keep practicing and make some changes on how you're blowing into your straw and how much thrust you give your rocket. Now, if I wanted to, I could try some different things. There is a sheet that you can have that I have provided for you with some different rocket activities that you can try. So you can see how accurate you can get with hitting your target. Do you get close or do you go way past your target? Do you hit it in the center or do you just kind of nip it around the edge? What you could do is start near your target and then step back one more step each time and see how much more thrust you need to use to get to your target. If you can go outside, what's the farthest distance your rocket can fly? And then mark that spot with a piece of tape and then see if you can go farther. If you have family members with you who have also made rockets, then see if you can have a friendly contest and see whose rocket goes the farthest or the straightest. Now, if you have built your rocket and then you have time, which I think we all have time these days, we can make it better. Engineers have what they call the engineering design process, and they're always making their products better. They start with a rocket. For example, if I start with my rocket and I see that maybe it's always going crooked, what could I do to make it go straight? I can ask myself a question, then I can imagine what I want to do to change it. I can come up with a plan. Then from that plan, I can create a new part on my rocket. I can fix it somehow. I can try it out and see if that improvement works. And then if it does, great. If it doesn't, then I can ask myself, what could be better? And you can see it goes right around in a circle. So if there are improvements that you can make with your rocket, if it keeps flying crooked, what can you do? If it doesn't fly very far, what can you do? So after you've tested your rocket for a while, go back to the design table and see what you can do. If you add weight to it, what does it do? Does it fly farther? Does it go straighter? If you add more flaps, if you change the position of the flaps, if you do different things to your rocket, what will happen? Okay, well, I hope that you have enjoyed this lesson in rocket engineering, and I hope that you'll go out and use your rockets and have some fun. See you next time.